Hi class, we're gonna go over the second problem from the probability activity, and this one's a little bit complex due to the wording that they're actually mentioning. So, for example, one of the requirements that they're referring to here is the following. So you're looking at a deck of 52 cards, which is technically this deck of cards, and we're gonna do a selection. So we're gonna be selecting 6 cards, but within this selection there's technically 2 events occurring. So one event is you're gonna be obtaining 4 face cards. So that means that out of these 12 ones, you're gonna be selecting 4. And that actually means that if you select 4 from here, and the total happens to be 6, so that means that from here, you're gonna be selecting, so select a total of 2 cards from the rest. So there's technically 2 events. Now, because of the wording of exactly, in this case, 4 face cards, so there's technically 2 events within the selection of the 6 cards, a specific rule comes in, and this rule is defined as the Eminent Rule. And the rule basically says the following: if you have 2 events occurring, and each of these events have specific amount of ways that they occurred, in this case M and N, the way that both of them occur at the same time is M and N. So technically you multiply these two. Also, because you're selecting cards from a deck of cards, and in this case order doesn't matter as long as you have 4. And if you were to select these 4 into one hand, they count as a single selection, so they don't count as different, because as long as you get these 4, it counts as one of the hands. Technically you're going to be using the formula. In this case, the formula is the combination formula, and this is what you punch it into the calculator, like in terms of NCR. So let me give you like a quick example. So let's say you do 4C2, and if you evaluate this in the calculator, you would basically say 4, then hit math. At this point, you activate the NCR and then select 2. This gives us the values of 6. And let me just double check. We're getting 6 there. This is just for you guys to run it in the calculator. What this formula does on the background is it evaluates how many ways can you select 2 items from 4 where the order does not actually matter. Okay, so let's take a look and apply that formula to what we're going to be evaluating here. And our basic events are going to be mainly 2. And one of them is going to be the selecting of the 4 face cards that they're requiring. And the second event is going to be that, well, since you need 6 cards, remember that 6 total cards. And these 6 ones technically get broken down into these 2. So 4 have to be face cards. The others can be technically any cards. So we're going to be selecting from this chunk a total of 4 and 2 from the rest. And in terms of the sample space, your sample space gets evaluated in the following form. So this would be 52C6. This is the total amount of selecting 6 cards from a deck of 52 cards. Now, let me evaluate it on the calculator just so that you see it. I have the code there, but here you would do 52, then hit math, move all the way to the PRB, and then activate the NCR. And then at this point, you would hit 6. That's how it goes into the calculator. On the file, I'm just writing it as 203, 58, 520. That's the sample space, or the total chances of selecting 6 cards from a deck of 52 where order doesn't matter. So we're not counting order as a separate selection. Now, one of the events which is a little bit messy is the ways of selecting the 4 face cards. Because your face cards come from this chunk here, you have a total of 12. And then technically the rest of them, you're going to have a total of 40. So in order to select, 4 from 12, which is your face cards, you will be evaluating the 12C4, which I already punched it in here, and this is 495. So let me show you again in the calculator. You would do 12 math and then move to the PRB, NCR, and then 4. And then the last portion is, well, that gives us the total ways of selecting 4 from the 12. But the last portion of this is we need to complete the 6 cards. Remember that the event has to do with 6 cards. So in order to do that, we're going to be evaluating a total of 2, but from the rest of the 40. So I'm talking about from this chunk here, we need 2. So in order to evaluate the selections, this will be 40 C2, which I already calculated at 7 and 80. Let me run it just so that you see it. This will be 40 math and then 2. So 780. Now, the next calculation is crucial because, well, the way that they worded the problem, you have to have technically the main requirement of the 4 face cards. So here on the background, what we have is the Eminent Rule. So by the Eminent Rule, we're going to have the following. The probability of A, and I already declared A, which is selecting a poker hand that has 6 cards, and it has to have a total of, 4 face cards. It's going to be evaluated as follows. So in order to do the selections of the proper cards, you're going to be evaluating 12C4 times the 40C2 out of the sample space. And our sample space came out to be 52 C6. That goes in the denominator. So in this case, the 12C4 ended up being 495. The 40C2, which is the other 2 cards, it's equal to 780 over that huge number 203 58 520. So please punch it into the calculator and let me tell you what I'm getting. So I'm getting 0.018 96.5, and this one is also picky in the rounding. They want 5 values, so 1 2 3 4 5. So rounding to 5 values, I'm just going to rewrite it as P of A. It's approximately 0.01896. So just the wording on this specific one actually introduce 2 main additional formulas, which happens to be the Eminent Rule, which requires a multiplication of the 4 cards and the other 2 cards, or the selection of those cards. And then also for the selection, well, we need the combination rule. So that's actually it for this one. It did turn out to be a little bit messy, but that is pretty much it. Also, don't forget 5 values in the rounding.